Hello, everyone. Let's get the meeting started. And in a moment, I'll get the countdown. We'll be broadcasting live on YouTube. And we're doing a sound check right now. Okay, here we go. Good evening, everyone. Welcome to the June Recreational Astronomy Night meeting of the Toronto Centre RASC. My name is Paul Markov. I'll be your host for this evening, and I'll be introducing the speakers. The speakers for tonight are Chris Vaughan, presenting The Sky This Month, followed by Patrick McDonald. He'll be talking about adventures with the naked camera. Then Charlene Norgrove will talk to us about creation and evolution of an observatory, Pic du Midi, 1851 to 2016. And finally, Brian Zarnick will wrap up the evening with a presentation by the name of Fire in the Sky, Reporting Fireballs. So a reminder to our speakers to watch the overuse of acronyms. If you use acronyms, please explain what they mean. And do we have any new members or guests here for the first time? Hands up, please. Wow. Very good. Welcome. Hope you enjoyed the meeting and to see you again. So without further ado, before we get to the presentations, I'd like to call on our President, Ralph Chu, to do an award presentation.
Thank you, Paul. One of the pleasant duties of the President is to pass along awards to various members. And we have a number of different awards that we offer to recognize service and volunteer activity by our members. On the weekend at the CAO, we're going to have the awards picnic and presentation of some special awards. But tonight, I'm going to be presenting two awards, which are through the Ontario government. And these are the Ontario Volunteer Service Awards. They are part of the Ministry of Citizenship and Culture's program to encourage citizens to do volunteer activities to contribute to their communities. And as a charitable organization, we are entitled to nominate 6 adult members and up to 2 youth members for their service. And we fortunately are able to, in fact, meet our quota, as it were. And for this year, which was to recognize contributions up to the end of December of last year, we did have a number of people who were invited to a ceremony on June the 6th. 2 of our members were unable to attend that evening, but they are here tonight, and so it's my pleasure to be able to present them with a certificate, which is suitable for framing, as well as the volunteer service pin, which is a lapel pin, and for this year, to mark the 150th anniversary of Canada, they're also providing an Ontario 150 pin as well to all the recipients. So again, these are for longer-term service, and they're provided to our adult members in steps of 5 years. And the first award here tonight is to Stu McNair in recognition of at least 5 years of service to the Centre, particularly in his role, which he held up until last fall as chair of the Observational Activities Committee. So, Stu, you know, please. Our second award is to Rajesh Shukla in recognition of his service for at least 10 years. Rajesh took over the website on the untimely death of his friend Andy Shu and was responsible for recovering a lot of the web materials as well as the operation of the Yahoo listserv after Andy's untimely passing. And his most recent work has been as one of our volunteers at the David Dunlap Observatory up until last summer. And Rajesh was one of the people who ran the 74-inch telescope and helped a lot with the maintenance of the telescope as well as the physical plant itself. And in fact, he was our last director of the observatory during our tenureship there. That ended last December. So Rajesh, please come forward. So again, thank you, Stu, and thank you, Rajesh, for your service. And again, we appreciate very much all you've done for us.
Thanks so much, Ralph. And I'll call on Chris Bond to present the sky this month. Ask for the air conditioner to be turned on or cranked up before.
Can you hear me? There we go. Start with the sparkly one. So yeah, so great to cover another interesting month of astronomy. Hopefully we'll have a lovely month of clear weather where we can get outside and see the night sky. We just have to wait for it to get dark. That's the only problem. So what I'm going to cover during this next little while is a little bit about what's happening in space exploration, some remembrances of this month in history, and then for observing, we're going to cover what's up with the moon, the sun, comets, asteroids, what are the satellites doing, an occultation dimension, some summer targets, and I'm going to mention all my times in Eastern Daylight Time, which is Universal Time minus 4 hours. The content of the presentation is assembled into a handout, which I'm going to upload to the RASC website either tonight or tomorrow, so everybody can get all the details. So some headlines in case you're feeling a little drowsy and you want to have a nap. Here's some of the highlights of what I'm going to talk about. Of course, today it's the solstice, so good news, the nights start getting longer from this point on. Saturn is also having its solstice. Saturn's seasons are much longer than the Earth. They're about 7.5 years each. But Saturn's first day of summer is starting around now, and so its rings are open the widest, maximum width. So it's a great time to be looking at Saturn. Great news, summer Milky Way season is here, where all the wonderful objects are visible over our southern horizon. Tomorrow morning, if it's clear, a bit of a challenge, but the moon is going to occult Aldebaran. It should be visible in a telescope if you can find the crescent moon, and I'll give you some details on the timing as we go. This weekend is the new moon, so it's great for a nice dark sky, and I'll mention a few comets that you can vacation in the nice dark sky. Tuesday, June 27th, there's an asteroidal occultation that passes over the GTA. How's that? Okay. Charlene, I hope I didn't steal your thunder by showing this picture from Damien Peach taking it. Is it? Sorry. Yes, it to 2016. Back online. All right. Wednesday the 28th, you can look for the planet Venus to cross very close above the Hyades cluster, forming the face of Taurus, the bull in the pre-dawn eastern sky. And on Friday the 30th, the moon is going to occult the double star Purima, which should give us a chance to see the star wink out in 2 stages. And finally, on the 4th of July, something new for me. I haven't looked at this before, but it's an effect called the golden handle on the moon, which I'll go into a bit more detail on in a bit. I listed in the handout a number of upcoming rocket launches. A couple of the more upcoming one or the more imminent ones are SpaceX launches over the next few days from Cape Kennedy, and there's a number of others listed in the handout. None of them are, they're all basically communication satellites and nothing too glamorous from an astronomy or astrophysical point of view. A bit of an update on some space missions. So we have, this is a summary of sort of what's happening in the sky, in the solar system, for all the various locations, so Mars, Earth, and so on. And I want to highlight particularly these missions. So the OSIRIS-REx mission, which is on its way to rendezvous with asteroid Bennu, has done a loop of the Earth, and it's coming back to do a gravity assist within the next couple of months. It'll swing past the Earth and get a boost to send it out to the asteroid. And New Horizons, which was the spacecraft that flew by Pluto, is now halfway to its next destination, which is the Kuiper Belt object 2014 MU69. So that flyby will occur January 1st, 2019. So we're looking forward to that. A little bit about Juno, the Juno spacecraft, which is orbiting Jupiter right now. If you listen to the Planetary Radio podcast, they had one of the principal investigators on that show recently, and I made a few notes as to some of the interesting things that he commented on. So already 44 papers have been derived from just the first 2 flybys of the planet. They're finding out that the atmosphere is much more variable than they thought. Even just below the belt and zone cloud tops, they're finding so much dynamic variability in the atmosphere, despite the fact that the sunlight can't reach to those depths in the clouds. They're measuring the gravity and magnetic field of the planet in detail, and they've been surprised to find out that the core does not appear to be sort of compact and uniform, but it's more fuzzy. It's got some 3D geometry to it, and it's much larger than they thought. Perhaps up to 50% of the volume of the planet would be considered the core, whatever that exactly means. And there's still science being done to work out exactly what that could be all about. The aurora, you may have seen pictures of the aurora around Jupiter's poles. They discovered that to a large part the aurora being fueled by emissions of particles from within the planet, not just from particles arriving from the sun, which is a big surprise. And this one's cool. The next pass happens on July 1st, is directly over the Great Red Spot. So we should see some fantastic, never-before sight of what the Great... Sorry? First... The 11th of July, sorry. The 7th pass on the 11th of July. Yeah, flying directly over the Great Red Spot. Now here's a video, if I could get this to play. Will it play? Just about 45 seconds. Okay. So the spacecraft has an imaging system called JunoCam on it. And all the images are archived in a database which citizen scientists are allowed to access and create processed images and videos. And I just wanted to show an example of an image of a little movie that's been created. Won't play? All right. Well, the link is in the handout, so you can always watch it at your own leisure. So we'll move on. We're trying? Okay. Cassini mission, as you may or may know, the Cassini mission is in its swan song. The end of mission will happen on September 15th when they'll crash the spacecraft into the planet in order to avoid any possibility of the Cassini spacecraft contaminating any of the moons of Saturn. And some of the interesting things that the spacecraft has been up to recently might surprise you. So the radar system that had been previously used to map the large moon Titan is now being used to probe the rings, both passively and actively. So they'll be beaming radio signals at the rings and getting reflections, but they're also listening for radio emissions from the ring particles. The ultraviolet spectrograph and the visual and infrared mapping spectrometer instruments have actually been observing occultations of the sun's light through the planet's atmosphere and the rings, but also occultations of stars. So they've recently observed an occultation of Betelgeuse because it's a red star, and they've got an occultation of Alnitak because it's more of a blue star, and they can compare the way the wavelength of the stars with the different spectral components react by passing through the atmosphere and the planet's rings. They've also been setting up occultations around some of the minor moons. So the moon Tethys is thought to perhaps have an atmosphere, and they've been looking at occultations of that moon in front of distant stars to see if they can pick up any atmosphere around those moons. The radio beacon of the spacecraft has been monitored for Doppler shifts that would be indicative of gravitational accelerations on the spacecraft as it plunges between the rings and the planet in order to measure the weight of the rings. That's the ultimate goal, is to see how much the rings will weigh. And the imaging system has also been taking good long looks at things like Enceladus's icy plumes and things like that. So, as I said, the grand finale happens on September 15th, but until then, we're getting plenty of science out of the Cassini spacecraft. This is just a graphic of the showing the some of the data and the sort of the transparency of the rings radially and also longitudinally around the planet through one of these occultation events. Okay, and this month in history, in terms of astro birthdays, on June 26th, we celebrate the birthday of Charles Messier, who we're all very fond of. And of course, he was the one that was tracking comets and created the catalog of his so-called black list of dim fuzzy objects that are not comets and that were annoying to him. So he decided to tabulate them so that he and all of his comet hunting colleagues would not be fooled. Then on July 7th, we celebrate the birthday of Piazzi, who was famous for discovering the asteroid Ceres. July 7th, Robert Heinlein, the American Dean of Science Fiction, was born. And Alvin Clark. Alvin Clark is the son of the original Alvin Clark on July 10th, 1832. And he, using one of their big refractor telescopes, was the first person to observe the white dwarf Sirius B. I like mentioning women astronomers when I find them. This one is Mary Lee Shane, an American astronomer, and her specialty was analyzing the spectra of the interstellar medium. In terms of historical events in history, on June 30th, it's the anniversary of the Tunguska air blast in Siberia, which happened around 7 a.m. local time. And interestingly, the scientists weren't able to get to the site and investigate for a number of years later, and not photograph it until many years later, 1929. July 1st, 1917, the 100-inch Hooker telescope mirror arrived at Mount Wilson, and at the time, that was the telescope that was bigger than the David Dunlap telescope, 74-inch telescope there. When it opened in 1935, the 100-inch was the bigger one. July 4th, 1054, the original firework was the Chinese astronomers first observing the supernova that has now become Messier 1, or the Crab Nebula. and that was documented in their writings, and so we know exactly when that supernova first was July 4th, also in 1997, was the anniversary of the Sojourner Pathfinder mission landing on Mars. July 6th, 1687, it's Newton publishing his Principia Mathematica with Tesla's 3 laws of motion. And on July 7th, something crashed in Roswell, New Mexico. We don't know what. Continues to fascinate everybody. July 16th is the anniversary of Comet Shoemaker LEV-9's fragments plunging into Jupiter and scarring the planet's surface for a while. Here's a picture of the fragments beforehand so the comet did a pass of the planet, got broken up. Those fragments made an additional orbit and then were captured finally by the planet's gravity and all functioned of it. And July 16th, 1969, the Apollo 11 launch. So, into observing now. The Globe at Night program is a way for people to contribute to science around light pollution. So, during the observing periods every year, people are requested to go out under their night sky, wherever they happen to live, and see how deep or how dim the stars that they can observe from their location. So the focus for the July and June campaigns are the constellation of Hercules, and these are sort of the finder charts they give you to compare what you see. So here's to be a very magnitude 0 or magnitude 1 cloudy sky or extremely light polluted sky. And then as you get into more rural sites with less and less light pollution, you'll pick up more and more stars. Can you see Hercules? Hercules is the little keystone right there. So here's the website, globeatnight.org. The observing campaign for June is underway right now until the 25th, and then the July campaign will pick up on the 15th to 24th of July. In terms of what the sun is doing, the summer solstice I mentioned is today, was this morning at 12:24 a.m. And we're also approaching the time of year when the Earth is closest to the sun, which happens on July 3rd at 4 p.m. July 1st? Yeah, in the handbook it's the 3rd. Farther. Sorry. Farther. Thank you. Astronomical twilight. So astronomical twilight is the term we use to describe when the sky gets fully dark, when the sun is sufficiently below the horizon for essentially the sky to be indistinguishable from the horizon. And that occurs when the sun is approximately 18 degrees below the horizon. Astronomical twilight today ends this evening at 11:25 and picks up again at 3:13 a.m. So that for imagers, that only is giving you just under 4 hours of imaging time this time of year. And that's about as bad as it gets, seeing as we're on the solstice. Then on July 19th, at the time of our next meeting, the amount of imaging time has grown by about an hour to 4 hours and 41 minutes. And here's just a little graph of the sun. This is the distribution between daylight, the amount of daytime versus the amount of nighttime through the year. Here we are sitting today at the worst possible day. And you can see that at, say, even a month from now, we're starting to swing back and the days will be growing shorter and the nights longer at a faster rate. But we have to live with the sort of late sunset for another couple of weeks. For the moon, these are the various events for the moon. The big one, of course, is that this weekend is the new moon for the month. And the next full moon is the full buck, thunder, and hay moon that happens on July 9th. So here's the golden handle effect. Essentially, it's the Montes Jura, which is in the, from our perspective, the upper left quadrant of the moon's disk, and around towards after the last quarter moon, which occurs on July 4th in this event, the sun's light is shadowly hitting the moon, the Montes Jura around Merindium and creating this sort of a semicircular handle effect. I've also seen it referred to as the jeweled scimitar effect. In terms of what the planets are up to these days, so Mercury is just about to start a very good evening apparition for us, and that will basically last all the way over the next 3 or 4 weeks until the next meeting. The only interesting thing of note that Mercury will do is it'll be climbing past Mars on the 28th, but both planets will still be fairly low into the murk, so very difficult to see those. Venus has been hanging out in the eastern pre-dawn sky for quite some time. It's continuing to do that. It's going to be rising at 3 a.m. even over the next month, because even though it's starting to swing sunward, the ecliptic is tilting it higher, so it's sort of maintaining its height. And if you get a chance to see it in a telescope, you'll see that it's showing a partial phase right now, which will be slowly waning a little bit through the month. And as I said, on July 12th, it's going to pass right over the Hyades cluster, so you might make a nice photo opportunity. Jupiter is sort of past its prime, but it's still a nice target for us in the southwestern evening sky. It's about 9 degrees from Virgo's bright star Spica, but yes, do look at it sooner than later because it's soon going to be gone for the year. The first quarter moon will be sitting about 4 degrees from it on June 30th. And here's a little close-up detail of 2 events. So this is the June 30th, 4 degrees from Jupiter, but also that same time the moon will occult the double star Porrima, and I've got a bit more details on that coming up in a minute. There are about 5 single shadow transits, so the moons of Jupiter, the 4 largest ones, will cross the face of the planet and cast black shadows on the planet if you know when to look. And I've listed 5 observable events in the next 4 weeks in the document that I'll post online. This is the one for June 26th, shown at about 11:30 p.m. with Io's shadow transiting across the face of Jupiter. In terms of Saturn, Saturn is sort of sitting just in the Milky Way or beside the Milky Way. It's in Ophiuchus, and it's unfortunately, as I said, even though the rings are nicely wide open for us, due to the low nighttime ecliptic, Saturn will not get very high in the sky, so it will be dampen our good views of it, but definitely still worth a look. On the 6th of July, you can look for the moon sitting at about 2 degrees above Saturn. Uranus and Neptune are kind of in the post-midnight to pre-dawn sky right now. Uranus is in Pisces, and it's about magnitude 5.9, which is certainly within view of binoculars. But by the time of our next meeting, it'll be rising about the middle of the night, about 12:30. Meanwhile, Neptune, which rises earlier, is about magnitude 7.9. It's sitting just in Aquarius, and after mid-July, it'll become an evening target, rising about 11 o'clock. You might want to try your hand at seeing an asteroid. So the asteroid Juno, here's the path over the next month or so. It's sitting at the north tip of the constellation Scutum, which puts it about 1.5 degrees above the Wild Duck cluster now. And then in the next couple of days, it's going to swing very, very close to this little star that's at the top of the constellation called Beta Scuti. So that would be a nice little thing to see in a telescope and give you something that sort of guide you to picking up the astro. I'd like to report on what the Minor Planet Center is compiling in terms of objects. So already this year, they've picked up another 108 near-Earth objects at a rate of about 140 a month, bringing the total to 15,000. Near-Earth is 108, but altogether, minor planets newly discovered, is 15,245 just this year, or about 2,600 a month, and already 29 new comets this year. And that's based on 8.5 million observations since January 1st. Here's a few comets that have been sort of visible in the sky under binoculars or small telescopes. So Comet Johnson is actually sitting, it's sort of passing through the legs of Virgo right now, and it's in the southeastern evening sky after dusk, and sets about 3:30 a.m. local time. And I've got the finder charts that I'm putting in the presentation in the handout. Comet 41P Tuttle Jacobini-Pressak is observable in the southeastern evening sky. It actually rises and culminates across the meridian, or so about 1 a.m. local time. And so it's we've got a fair bit of time to see it, and it's about magnitude 8, and gradually dimming. It's already past its peak. And it's sort of running through the eastern part of it. And finally, Comet Pan-STARRS, that's ER61 Pan-STARRS, again about magnitude 8. It's in the pre-dawn, and it's running over the next month or so, sort of parallel to Aries, just above Venus. There's Venus there, so it sort of gives you your guide of where in the sky to keep an eye out for Pan-STARRS. Pan-STARRS has recently peaked in brightness, and it is dimming fairly rapidly. In terms of the space station, we're really stuck with only morning passes right now. They start again on the 5th of July. So we have no passes until the 5th of July, and then they start in the morning then, mostly between 2 and 5 a.m. No evening passes at all between now and the next meeting. If you want to get up and look at some of the morning passes, they're for crazy hours, but there's some brighter ones there for you to look at. Iridium flares. I encourage you to observe an iridium flare if you haven't already done so, because the Iridium company is already launching their replacement for the Iridium satellites, and they're deorbiting these ones shortly. So get out and take a look. If you want to know when they're happening, you can look at the website heavensabove.com and type in your location. It'll tell you when to find them. You can also use smartphone apps through a phone or tablet. I list them in my weekly skylights, so you can also just pop into there, and I've got them all for the week for the GP. Here's the asteroidal occultation. So pop up the air bars here. So June 28th, that's actually June 27th, around 11:12 p.m. The asteroid 83 Beatrix is going to occult the star, and this is the predicted center line for the occultation. The blue lines are the plus or minus 1 standard deviation. You can see that we're within the error bars for that occultation. Drops 1.44 magnitudes for 13.2 seconds, but it's only 21 degrees up. This star is located near Antares. It's in Scorpio. But it might be something worth doing. Here's tomorrow morning's occultation. The weather is looking dicey, but Aldebaran should be bright enough to see in a telescope if you know where to point it. So if you have your telescope out tomorrow morning, be careful not to aim it anywhere near the sun. The sun will be up when this happens. But you can certainly find the moon, and don't use too strong an eyepiece. Give yourself a nice, comfortable field of view, and you should be able to spot Aldebaran to the left of the moon before 9:42 a.m., and then it will egress at 10:54 a.m. So it's a challenge, but it might be possible to try that. In terms of what's up along the meridian this month, of course, you want to observe objects when they're highest in the sky, because they're be shining through less atmosphere, and so we like to see them when they're on the meridian. And the constellations that are on the meridian at 11 p.m. over the next little while would be Lupus, Western Scorpius, Libra, Ophiuchus, Hercules, Corona Borealis, and so on. Then at 1 a.m. we get into Scorpius, Sagittarius, Scutum, Ophiuchus, Serpens Cauda, which is the tail of the snake, so to speak, Hercules, Lyra, and Draco. And then if you're a night owl and staying up all the way to 3 a.m., then you can start picking up things like the rest of Sagittarius, Capricornus, Aquila, Delphinus, Sagitta, Vulpecula, Cygnus. In terms of what you can chase this weekend, in particular with the nice new moon sky, this is a graphic made in Stellarium of the southern and eastern sky. This is just showing the distribution of the Milky Way, and those are all the Messier objects that you could chase down this weekend that are available in the sky between the south and the east. And if you're interested in some other showpieces that Messier did not include in his list, you could try the Caldwell objects. These are the Caldwell objects. We're only going to get about half of them because they actually range all the way from the North Celestial Pole to the South Celestial Pole, whereas the Messiers are only Northern Hemisphere observable. but there's a number of Caldwell objects. Just to put everything together, there's the whole shooting match through the south and eastern sky. And then don't forget to turn around and look north. There's a whole bunch of other Messier and Caldwell objects that you can see sort of around the Big Dipper area. Some of these will be setting and quite low, but you can certainly tool around in the northern celestial pole and pick up a lot more interesting objects, especially galaxies. So the little red ovals here are galaxies, visible because they're out of the plane of the Milky Way galaxy. So we'll see you at one of our star parties. Thank you. Question? The image I showed was the visible image from the Juno cam. The information that I mentioned about the clouds at depth are yes, they're coming from different spectra. I don't remember exactly what they are. Yeah. Great, thank you.
Am I on? Good. Hello, Internet. Hello.
Especially over there.
Oh,
that camera there.
Well, it just goes to show you how.
We're gonna have to outfit you here. So this one goes around your ear.
Yes.
This one I can probably put in the pocket. Is that okay?
What is this going to do exactly? I have to give this back, right? Does this make me sound louder? Oh, it's making the computer. Gotcha. Okay. Well, the answer is, of course, no. Now, many people these days have, and I'm afraid this is an acronym, DSLR cameras. That stands for Digital Single Lens Reflex, which is just, any of these cameras where you can see the picture immediately on the back. Which one is it? This one? Where did I point it? It's not doing anything. Yes. Now, the one I have is a Canon Rebel C5. It's the one with the plastic case. You can get the C5i, which is the one with the heavy metal case, which is much more impressive. But of course, if it's on a tripod or something, it sort of puts more strain on things. It also self-cleans, which I suppose is handy, although I have seen my cat clean herself, and I really do not want to know what goes on in that camera. But why is it reading? So, I don't know. See, the thing about these DSLR cameras is you can change the sensitivity, the ISO rating, way up to like 6200 or something. So it makes it quite possible to get nice shots like this, just handheld. Plus, of course, the lens usually, you sort of fiddle it and it gives you a closer view of the sky with greater magnification, and you can, of course, see. I'm going to do this, and it looks my block. I won't go back. Oh, that's the laser thing. Anyway. Okay, now how do I make this move? Here. Well, look this way. Even with an ordinary camera, zooming in, you get Venus, Mars, and that lovely old moon in the new moon's arms effect. This is just, here's the light coming from the sun, bouncing to the earth. It bounces off the earth, off the moon, and then comes back to the earth. That takes about 3 seconds. So this is really 3 seconds older than this. And another great thing about DSLR cameras, you can take a quick shot, try it with 1/500th of a second or something, and then just pick, ooh, too dark. Make it 1/250th of a second. Tick, great. Now I can seriously, focus and things like that. In the old days, you had to send the slide film in to Kodak, and about a month or two later, it would come back and your slides would all be ruined because you had under or overexposed them. And I've always found that if you get a nice crescent moon and a planet or two and something in the landscape, you get nice pictures. You can frame them and send them to your relatives. Now, I guess you can't reduce the light that's bouncing off the screen, so yes. Somewhere here, oops, wrong button again. No, it's doing the wrong thing. Somewhere around here, I think, is Venus, and on my... Can you guys see it? Because looking up close at it, it sort of vanishes because of the pixels. When I look at it in my, you see it? I'll just stand back so you all get a better view. Where is it? Show them with the laser pointer. Or use photo zoom. This looks much better on my computer screen at home. Maybe the resolution is higher. I mean, you can still get good pictures, even though occasionally the hardware lets us down. Now we're going backwards here. Okay, this was a few years back. You've got crescent moon, Venus, and over here is Jupiter. Plus, Toronto skyline is sort of reflecting in the water. That's always a nice thing, if you can find the right spot to do it. And you notice that so far this is all just you and your camera. Nothing else. I like slides better, they do all these exactly right. So, the bottom one is it. Now, you don't need the moon. You can take pictures of planets only. Jupiter, Mercury, Venus. This was a 3-day event where they constantly shifted the shape of the triangle. And it was historically significant. It's not the best picture in the world. But on the other hand, you can show it to people and say that sometimes you get 3 planets all together. Yeah, Venus is the bright one at the bottom. Mercury is just to the right of the sign. Jupiter is to the right. This was at the, what's the one where they all dress up like ponies? Anime North. Anime North Science Fiction and Fantasy Convention. As I recounted once before, this is at the end of a dark alley looking out over the parking lot. And I had told this group of young people that if they followed me into the dark alley, I would show them something really beautiful. Security misinterpreted. So after much explanation and, showing actual objects, I was not charged. But you have to be careful. Yes, Mercury, see? How many people in this room have actually been able to see Mercury? Come on, fess up. How many haven't? It's all right. Some of the famous British astronomers, because first of all, they're way up in the northern latitude, and well, you know what the weather is like. They went through their entire careers without ever actually seeing Mercury. So if you can take a picture of it, when you at an astronomy convention or something, you can pull it out and show, prove, in fact, that you have seen Mercury. It's always to be close to the sun. Beg your pardon? Yes, well, there's like 5 or 6 shots. These clouds were whizzing by fairly quickly. About half the shots, Mercury isn't visible. You just got the cloud. Venus was a bit higher up, so of course it was always there. I was really glad that I got Mercury that early morning. Assuming you will all be using the color setting on your camera rather than the black and white, which is possible, but there is a funny deep copper color that you get during a lunar eclipse. It's very much like a Maxfield Parrish poster for those with an arts background. It's just sort of otherworldly. Oh, that... Why do you jump two when I don't... This is Saturn, and this is Regulus. We need a nice pattern that time. And of course, another good thing about lunar eclipses, you don't have to travel to bizarre places to actually see them. Now, the next step up is to get one of these things. A tripod. What is the purpose of the tripod? It is steady. I mean, assuming that, there isn't a garbage truck going right by the sidewalk, or that you're not walking on a deck that is very springy in its boards. If you set it up with a tripod and just put it to bulb, which means I will stay open until you tell me to shut up, you get nice effect. This is, of course, going around Polaris. I always feel it looks a bit like a whirlpool drawing you in. My cousin liked it. I think he's got a copy on his shelf. It was taken in his backyard. Bless you. Bless you too. Yes, this is not as bright as I had hoped it would be. There, see that little fuzzy blob? Here's the familiar outline of Perseus. There's Algol. This was Comet Holmes. A few years back, you remember, it was bright enough you could see it literally at college in Spadina looking up. I accosted several people and forced them to look up. But just putting it on, just taking the picture for 25 seconds on the tripod, and lo and behold, you've got a picture of a comet. You don't need 5 hours. This is the next step up. The iOptron tracker is a funny little device. The only way you can really make it work is to buy the optional ball head, which just allows you to tilt the camera at unusual angles. You also need the tripod, and of course that's hardly ever included. Your best bet is to get them used, or sometimes Ontario Telescope has them on sale. We've got one of these, don't we, in the RASC loaning program? Yes, so just make sure the person that sets up your loan from the RASC program and you take it up to the cottage shows you how to set it up. And the most important thing, if you don't have a smartphone, see there's an app. You push the button on your smartphone, it gives you this little double circle, which is what you see when you're looking through the polar scope. And it tells you exactly where Polaris should be. Exactly where Polaris should be, sort of going around the circle at that particular time. Now, I don't have a smartphone. I'm too old. But if you don't have one, you can just Google it on the web, and you will get a picture that shows you exactly where your Polaris should be at different times, Eastern Daylight Time. Print it out and put it in the little pouch that comes with this sort of golf club case that the whole thing sits in. And that way, you don't have to ask attractive young students from Trent University who are also on the bus to search their Google phones in order to get you the required information. Thank you. The eye upturn tracker. No, are we in focus here? It seems a bit blurry. Yeah. If you expose for about 2 minutes with an iopton tracker, you begin to pick up the brighter star clusters. Can anyone recognize this constellation? Yes. And there is the little triangle. And I think that one's Epsilon. Where's that one? That was the one that was going through the dark, mysterious cloud a few years ago. It does it about every 33 years. Every time we try and find out more about the dark, mysterious cloud. But you can see that you get enough to pick up interesting things. Also, at only 2 minutes, okay, I confess, I did go to Zoom browser and I pushed the contrast up. That just makes it look less gray in the background. This is, of course, the double cluster of Perseus, and there's a Perseid. And all you need is the camera and the iopton tracker in 2 minutes of your time. Now, you won't get a shooting star every 2 minutes in that part of the sky. But if you stick with one part of the sky and take, how many was it, about 24, 25 exposures, sooner or later you're bound to get lucky. This is the southern sky. There's the Omega Nebula. There's the Eagle Nebula. I think that's the Sagittarius star cloud. This was exposed again for about 2 minutes. The only problem if you're using the tracker thingy is that your trees and other landscape features get a little bit blurred because, of course, it's following the sky. So you notice that some of the stars seem to be keeping right through the branches because the branch is like this and the star is sort of going across like that. So it goes on and off. It's also a good idea because, unfortunately, this is from Bob Cajun, and the only light pollution dome is the city of Peterborough to the south-ish. So you might want to boost the contrast when you're manipulating your image. But you get a lot of the dark nebulae as well as the fun things to look at. In the old days, the orange Celestron 8 had a thingamy that you could send in for that would screw into a little hole, and like one half screws into the telescope cylinder, and the other half is a standard threaded camera mount thingy. I'm not even sure if they still make those. This goes back to the days of what I think of as real film. But this is what you can pick up. This is, of course, again, sorry. This is the Milky Way in the early 90s, about the time that that comet crashed into Jupiter. Jupiter was right in the heart of Sagittarius. There were pairs of meteors, and of course you have to wait long enough for one of them to point at the comet tail Lambda. It's all in the wrist. And this was about 15 minutes at ISO about 400. It's been a slide that has been transcribed. But you certainly pick up the dark lanes and the bright bits and all the fun things that there are. How many people have Zoom browser? It comes with your Canon camera. There's a little CD thing that you're supposed to put in your computer. Zoom browser is a very simple, user-friendly, how do I manipulate my image type thing. And the idea is that if you had a good image, you can just zoom in on part of it and say, I want this frame to expand to the whole image. It's called cropping for some reason. Well, nothing is harvested. So here is those 3 star clusters that you remember from the Auriga picture. The Capella way off there somewhere. But you're able to actually get what looks a bit more like one of these fancy astrophotographs as you're looking at a smaller part of the sky. And as long as your focus is good, it should come out. This is the Omega Nebula, which always looks like a bar to me. It doesn't look like an Omega. It looks nothing like the ones in the National Geographic, the Eagle Nebula. And of course you have a lot more of the stars going through the trees. But you've demonstrated you can pick up faint, fuzzy objects and blow them up so that it looks like a real astrophotograph, and all you had was your camera and the tracking device. Since we do have one available for borrowing, I recommend getting a brief tutorial on it just to make sure you're not tracking on the wrong point of the sky in which everything will be blurry. But you...
They borrow this, the Star Adventure is what we have.
Okay, so that works well. So, get out there. I mean, not here in the city, of course. Try and get outside the city to one of our many dark sky observing sites, trademark. And if you can't drive there yourself because you don't drive, I'm sure some of the friendly members of the RASC are only too glad to split the cost of gasoline and get out there. Long Sioux. Do we still go to Camp Robin Hood? No, it's... Yes, well, obviously. I think this is the point where I ask for questions. I'm going to drift back this way if the camera wants to track me. Yes? I seem to have stunned them into shock. Going once. Going twice. Now I have a... Ah, I see.
Another lens. What type of lens do you use on the camera? Just the standard one?
I've got two lenses. There's the basic one that comes with your camera. And there's the other one that is about 85 to 200. It's not one of those huge lenses that you see in the camera shop window where the guy, when he's taking it down to show you, has to bend over visibly, or two of them carry it together. No, it's quite simple to hold. It gives you a size of sky about, 10 full moons across by 8 full moons across. It's not an expensive one. Quite often at Downtown Camera on their used equipment shelf, they'll have one. No, that's the whole point of the presentation. You don't need the fancy stuff, really, except maybe for the track. Yes.
Photographing the space station, or having you myself doing so?
Well, if you mean as a bright, brilliant streak going through that little triangle of stars on Auriga's upper shoulder there, yes, yes. If you open it to sort of minimum magnification wide as sky, you will get a sort of a not so bright getting brighter, really, really, really bright, getting fainter, fainter type image of the space station. I know some people in the society have used video cameras, and they get these great shots of the space station going across the face of the sun. And they take each video frame, and then they make this one montage. So you've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 space stations going across the sun. That's, of course, through a white solar filter. Don't just point it at the sun. Not a good idea. And also the moon. I think there's even a website that tells you, if you give them your location, it will tell you if the space station is going to pass in front of the sun or the moon in the next couple of months. Yes, well, I have been teaching full-time for the past 3 weeks, and there are about another week and a half to go. And that's why I'm going to be slipping out at the end of this presentation, because I have a stack of grade 9 incorrigible science exam papers this high, and 2 grade 11 physics projects left to go before the other 2 loads of physics exams come in on Fridays. So, if there are no further questions, I hope you all have an opportunity to get out to a reasonably dark sky and see what that camera of yours can do. Oh, yes, of course.
Not so fast.
Yeah,
Yeah, actually walks by.
and Dad is still.
All right. That's all. That's all I needed from you. Thank you so much, Patrick. All right. Our next speaker is Charlene Norgrove, and she will talk to us about the PIC-UED Observatory in France. Come on down, Charlene. And we'll get you outfitted with this as well.
Okay, can we do this without the lights or not? Okay. Okay. So, excuse me, I took a trip to France a year ago, almost exactly a year ago, and part of the trip was a tour with a MWT Associates tour. Some of you are probably familiar with that. Peter, has gone with them. It's a tour group that does astronomy-themed tours. And he went to Pic du Midi Observatory in France, which you can see way at the top of that mountain. The story of this observatory is really remarkable. It's a story of perseverance under extreme difficulties. Oops. Okay. Not working. Yeah. Yeah. Okay. Okay, this is about the trip. On all of these tours, there's an astronomy expert along with us on the tour, and this time it was Robert Noya, who was the former editor-in-chief of Sky and Telescope. We spent about a week, just over a week with him. He can talk about anything. He went from gravitational waves to how Pluto was demoted. And you name it, he can talk about it at length. He's a wonderful speaker. I've given his name to Paul Delaney, because Bob said that he would love to come to Toronto and he'd do it at his own expense. He has friends here that he can stay with. So I'm hoping that maybe he'll appear next year sometime to give us a talk on who knows what. So, okay. So third slide. This is just a remarkable picture. And I changed my date on my presentation to 2017 because of this. Because this just was taken at Pic du Midi 10 days ago by Damien Peach. And this is what he posted about it. They seem to think it's the sharpest ground-based image of the planet ever obtained. And he says it's a testament to the exceptional seeing conditions at the observatory. He was impressed because Saturn was just 24 degrees above the horizon when he took the pictures, and he could still get images when it had dropped to 17 degrees. So it was still excellent images. So this was done at Pic du Midi. Okay, so we started out in Toulouse, up in the upper right-hand corner there, and took a bus down to. Is that clear? Is it? It's not clear here. Right here. Over to near Tarbes on the left there, and then down to what's La Mongie. And Pic du Midi is just up the hill there. La Mongie is the largest ski resort in the French Pyrenees. Okay, so here's La Mongie is. How do you get the other one? Just use that? Okay. So La Mongie is down here, and this is the cable car that goes up to Pic du Midi. Now, how did that happen? Okay, that's okay. Well, can we go back one? Okay, just wanted to mention that the elevation of La Mongie right here is 1,800 meters, and Pic du Midi is 2,877 meters. So that's a 1,000-meter climb. No roads. Cable car. So I used the word evolution in my talk, and that's what I'm going to talk about. It's sort of like this. Okay, it's not far from rocks on the right to briefcase and suits, which I'll mention later. Okay, so over the years, Pic has been a site for all of these things. It started out to be a site for meteorology, and it's worked its way through all of these things. It's now primarily astronomy and tourism. Here's what it looked like in 1878 when the first stone was placed there. So it's pretty primitive. Here's what it is now, 2017. It's a multi-purpose facility for astronomy, scientific studies, radio transmission, and tourism. I'll have some better pictures. Is it really clear to everyone? It doesn't look, okay, it doesn't look clear to me. All right. Okay, we're not going to go through all of this, but I put the date 1851 on here because that's when the dream started. That's when Dr. Kostelat wanted to install an observatory at Pic du Midi. He put up a station at his own expense on Soncourt Pass, but an avalanche destroyed it. Then a group of people got together for the Ramon Society to study everything about the Pyrenees. And in 1873, they established a temporary meteorological observatory in the pass. There were two men that were fundamental to the development of this observatory. Denan Souti was the research guy, the engineer, and Bossonat was the fundraiser. Both important. I thought this was interesting. Nansouty started staying there during the winter, but in 1877 they had extreme cold up there, minus 30, and he almost died. And he and his 2 aides had to leave the station. It took them 16 hours to descend a trip that would normally take 3 hours in summer. So this is just kind of a little aside, but even though I put 1851 on there, it actually started in 1706 when an astronomer from Montpellier decided to go to Pic Midi to try to study the solar corona during an eclipse. So this has a long history here. A couple of other little asides, just so you know what these guys were facing. The path up from the bottom up to the top has 7 to 12% grades, and it still exists. It's now used by shepherds and to transport equipment. That's how they get major, heavy, really heavy equipment up to that summit. Okay, so this is a photo I took out of the cable car. This is the path, and the Lake Once. So they're coming from down here, winding up this path. It's steeper than it looks from here. This right here, you can see some of the ruins from the original settlement from the late 1800s. So and I'm up here in a cable car. Okay, here's the 2 guys that were so important in establishing this observatory. Okay, here's an etching I found that was depicting the retreat of those 3 men during that storm. Okay, so they constructed a habitat up on the top so that workers who were working on the observatory could live there. And then in 1878, the first stone was placed, which you've already seen the picture of. In 1882, I think this was interesting. 2 observers from Paris came to watch the transit of Venus. The weather was so bad, they were unable to bring their equipment all the way up to the top, so they stayed at the building down in the pass. However, on December 6th, the day of the transit, the sky was clear at the summit and cloudy at the pass, so they didn't get to see the transit of Venus. But this was when the first tentative real astronomical activities commenced in 1882. This is probably worth talking about because plus ça change, plus c'est la même chose. Cost overruns. Okay. They thought it would cost 30,000 francs. It ended up costing, oops, sorry. We'll go back. There. Ended up costing 248,000 francs. They only had 200,000. So they gifted it to France, who took it over, and it became the National Observatory of France. And its first director was Vaucenin, and the Nansouty was the honorary director. So cost overruns all the time. And here's just some photos. Here's when the first stone was placed, that you've seen. Oops. Okay. These are just I think that's 1885 up here. An etching of what was up there, mainly the habitat for the workers. And I don't know when this was taken, but it's some more buildings have been constructed at this point. Okay, how did they do it? This was in 1875 or so. Observatories at 2877 meters. That's about 9,000 feet. The nearest village is 26K away, and it's at 550 meters. The intermediate point at La Mongie is 1,800 meters. They could only work during the summer, only accessible on foot, eventually with mules, but not until 1927. The great danger from lightning strikes in the summer. They could only work in the summer. And they needed provisions for those staying over the winter. So they did it. So how did they do it? They did it with men. These are the porters with their backpacks trudging up that mountainside. In winter, they went up 2 or 3 times a week to bring provisions for the people up at the top. One trip took from 5 to 8 hours. We heard a story when we were up there about one guy in the summer who was really fit. He would make up to 3 trips a day up that mountain and back, carting stuff up there. Okay, soldiers. I'm getting ahead here a little bit, but in 1906, the telescope for what you'll see, the Bayeux Dome, was transported from the base of Peak by 20 soldiers. There were 22 crates weighing between 3 and 800 kilos. After 1 month, they had transported the crate only to the pass. They had to leave them there over the winter, and then the telescope didn't arrive until the next September. Almost a year in transport. Mules! Starting in 1927, there was a track that was open, and they went up once a day. Each mule could carry 100 kilos. It carried up all the coal, 2 tons of potatoes, what it claimed, wine, bien sûr, of course, wine, wood, potable water, and other provisions. So that was real progress to get that track open. Excuse me. Emile Marchand became the second director of the observatory, and he wasn't satisfied with the inferior instruments they were using. Here's another little aside here. He did have a rudimentary telephone line installed between Peak and the village of Bagnères. The connection was poor, so they resorted to Morse code. The line was susceptible to weather and sheep, and it was made of copper, which was stolen. Same thing today. What can I say? People like copper, I guess. So, 1900, Benjamin Bayeux decided to install a real telescope up on Peak. So, from 1906 to 1908, am I doing that? Okay, sorry. 1906 to 1908, they constructed the dome and installed a 50-centimeter equatorial telescope. All materials and equipment were brought up by foot along rough paths. Weather was bad. Observers refused to go, so it was mainly the son of Benjamin, Jules, who used the telescope, and his work there won him a prize in 1924. In 1909, the Bayeux telescope was utilized to formally discredit the Martian Canal theory. Okay, so there's a picture in April of the dome under construction. I agree. See it there. All this snow. I guess they didn't have Mel and the National Guard to help them out at that time. Okay, so here's just a couple of pictures of the construction in various stages. Here's a postcard I came across and found. It starts kind of down here. You can see that there's just a big mountain of rocks there. So by here they've got the foundation built, and by here they have the dome on the foundation. However, they have a landslide. By here they fixed that, and here it looks like it's reasserted itself. But this is a later picture because the radio antennas weren't installed until about 1930. 1914, war. Marchand died. The observatory was left deserted except for one person. Part of the terrace collapsed. It was a catastrophe. However, it united people to try to preserve and renovate these buildings. Astronomers weren't enthusiastic. One said that it should be closed. However, in order to save Peak, Gauzer reoriented the work toward geophysics and scientific research, and this continued for over 14 years. And then in 1927, the track opened, so that the equipment could be brought up in the summer. Mr. Spy here. 1930 was another turning. Bernard Leo invented the coronagraph, with which he observed the sun's corona. He liked it, put it at Peak because of the transparency of the sky there. That's a picture I took of the coronagraph that's there right now. That's pretty much what it looked like. They almost closed the observatory yet again because they couldn't find anybody to direct it. But Jules, the son of Benjamin, found this plan insupportable, agreed to be the director even though he was already 63 years old. So he undertook an ambitious program of renovation, including a cable car and electricity. Okay, 1939, war again. Bayeux persevered. France was defeated and humiliated. And but this galvanized him and galvanized the French. His thought was, quote, "Our country needs to show that its genius and influence have not been extinguished." And so the period from 39 to 47 was very productive, thanks to the French government, who agreed with Bayeux. So they built 6 national observatories, 2 private ones, a high power voltage line, a high voltage power line, and using the telescope, observation of the moon's surface indicated a fine covering of dust. Here's a good story. I'll try to make it short. Bayeux wanted to upgrade the 50-centimeter telescope. He couldn't find something to borrow, but when the 41 opposition of Mars was imminent, they found a 38-centimeter one to use, and they made excellent observations of Mars in 1941. Leo thought about the 60-centimeter objective of the telescope at Paris Observatory. However, its focal length was 18 meters, 3 times that of the 50-centimeter at peak. So Bayeux and Leo fashioned a reflector refractor after the work of a Swiss astronomer. So the existing scope had 2 tubes, one for the 50-centimeter reflector, one for the 23-centimeter refractor that's used as a guide scope. They took out the partition between the two and knocked out and got bearings for, and 2 new objectives were ordered. And I think what's remarkable to me is that this work occurred during the fall of 1942 when southern France was occupied. They surmounted incredible difficulties of production, communication, and transport. And the scope was used until the early 1960s to do planetary work primarily. And here's just some photos of people using the telescope from 1909, 37, 56. So it was into the early 60s. Okay, I think I'm going to try to pass across this one. This was a proposal for an experimental telescope. They were innovative under all these circumstances that they were facing. This was going to be domeless, rigid tube with a mirror of steel. They had feasibility studies done by Messier, but problems occurred after the war in 1944. They could get no materials, and the country was essentially paralyzed. So the end of the war put an end to the project, which is probably just as well. But I thought this was interesting. The boss of French astronomy decided that no good images could be obtained at high altitudes. And he wanted to develop a competing site. So, okay. 1952, this was the real turning point. A cable car was installed and constructed. This marked the line, and I'm going to quote Emmanuel Davoust, between before and after, between those who had known the heroic period, when it took many hours of difficult climbing to reach the summit, and those who arrived up there in a suit and tie and with a briefcase, as if they had just stepped out of the subway. So after 1952, research really exploded. So here's the cable car. That's what it is right now. It's not the one they put up then, but the one that's now. It goes on a come and go principle. One goes up, one comes down. It's like this. 45K an hour, 15-minute ride. Car holds 45 people, but I don't know about. That's what they say. We had 25 in the car when we went up, and I wouldn't have wanted to put any more in there. There's one intermediate transfer station where you change cars to get up. The maximum height above ground is 350 meters. That's a long way down. The cars can be equipped with a 1,500-liter tank for carrying water to the summit. So all the water comes up in a tank for showers, drinking, everything. So there's a picture I took out the window of the cable car on the way up. The scenery there is just spectacular. Here's a few photos taken on the way down. So there's the cable car hanging there above the chasm. So if you're afraid of heights, you probably don't want to take this trip. Okay, more photos from the cable car coming down toward the station. The scenery is just spectacular there. I can't say enough about it. Okay, so things moved fast after 1952. Other telescopes were installed. and the television de France and building and mast were completed. I'll talk a little bit about that in a minute, but I primarily want to talk about in 1963, the 1-meter telescope was constructed for lunar mapping, and in 1980, the 2-meter Bernard-Leo telescope was completed. And in 2000, the observatory was opened to the public for the summer season for the first time. And this is what it looks like today. And that's a nice sunny day. Okay, so what's it like up there? Cold. It was nice when we were there, but it snows, falls 8 months of the year. 30% less oxygen. It's 9,000 feet, 2,800 meters up. Big floor area, 10,000 square meters. 5K a corridor. I think it was 1K to my room. We stayed overnight up there, so the complex is built on 6 levels, and I was on level 4, down. More. They've got transformers and generators at the top, fully functioning, up-to-date everything. Water treatment, firemen, emergency beds for lots of people, complete modern pharmacy and hospital facilities. In 2005, there were 108,000 visitors. And the visitor contribution, 3 million euros a year. Expected to increase with all night visits. So I tried to find my room. I leaned over the rail and was trying to find my room. My room is right down there. Room with a view. Okay, so this was the 16 of us in the group that went up there. But the room, there's accommodations for 27. Included in all this is a 4-course gourmet dinner, breakfast the next morning. So what does it cost? 339 euros single, 449 double. I suspect Melita, who is our tour leader right here in the turquoise, and here's Bob Noya right here. I suspect she probably got a deal because there were 16 of us and it was an astronomy related group. But it's worth it. This is my room, simple but adequate. Room with a view. Those windows opened. I had fresh air at night, fresh cool air at night. Fancy bathroom. 6 rooms shared a bathroom. Toilet, fancy shower. Fancy. Everything really nice and modern. Clean. And this was the view I had when I got up the next morning. Just really nice. Okay, this was just a couple of pictures of views from the top. Scenery is just wonderful. You're on top of the mountains there. Okay, so facilities, equipment, and such. I'm only going to talk about 1-meter telescope, which is dedicated to the observations of the solar system, and the 2-meter Bernard-Leo telescope, with a new generation stellar spectropolarimeter. I put this picture of the bezel in here. That's there. I didn't take a picture of that, but that's what this. We're studying the surface of the sun. Biodome was reassigned to become part of the museum in 2000. The interesting fact is that the observatory is good because it's close to the Greenwich Meridian, not far away. And here's what it looks like today. This is the Bernard-Leo telescope right here. Take a look at how it's constructed because that's important. It's away from everything else and it's high. This is the government building here and tower, and the 1-meter scope is not marked here, but it's this one right here. Okay, this building. It's a government building. You can't get anywhere near that. It's military, aircraft, telephone, television, and weather going in there. So what else does it have? Spies. That's what we were told anyway, is that they're listening to you. Okay, so here's the 1-meter telescope. So that's a picture I took, and we did have, it was foggy down around there in the morning at some point. It came and went, though, and then it was gone once the sun got up. So this was installed in 1963 and funded by NASA, used to take detailed photographs of the surface of the moon in preparation for the Apollo missions. Later on, they used this telescope to analyze the atmospheres of Mars and Venus, to predict that those planets had no life. The photos at the beginning of this talk, taken by Damien Peach, were taken with this using this telescope. Okay, so the Bernard Leo telescope. So it's built on top of a 28-meter column, 14 meters in diameter, and off to the side to avoid wind turbulence affecting the scene of the other telescopes. It's the largest telescope in France. Okay, so the 16 of us got a private tour of the telescope. Opened the door, and they let us in at the bottom of that. We had to climb all the way up. First thing we see is this: how to respond in case of a terrorist attack. So that set the tone there. So there's the big telescope. I didn't have a wide enough angle lens to get it with my camera, so I borrowed one from the internet. These are a couple of pictures I took. I got the mirror, and I think vaguely up here is the secondary mirror up here. I took this picture because this was July 7th. There's snow inside that dome, all around there. It was cold in there. Okay, so Narval. I could not find out what this stood for. I tried. It's an instrument. Narval in French means the unicorn of the ocean, the narwhals. No. But this is the only astronomical facility worldwide dedicated to stellar spectropolarimetry, studying stellar magnetic fields. This is the instrument right here. And if anybody's interested in how it works, I can tell them afterwards when I get my cheat sheet. It's a twin to the CAFH-1, so it allows coordinated observations between this one and that one over a period of 24 hours. Okay, we're almost done. Sunset. We had a beautiful, beautiful sunset on July 6th. And I have some photos I took. I couldn't pick just one, so I'm just going to rush through about 4 of them. And after the sunset, we got a little sliver of a moon there. And then we turned around. We were going to go over to another terrace toward the north to do some little bit of observing, and this was the sunset there. And here's a good way to see the clouds which are below you, which stop people from observing at lower elevations. We did a little observing on the terrace with a big dog that they brought out belonging to an amateur astronomy association called T60. They have permanent use of the 0.6 meter telescope, and they use it for public outreach. So we had a good evening looking at a nice clear sky on top of that mountain. So that's all I have. I appreciate you listening to me, and I hope you enjoyed it. And that's it. Any questions? Yeah, Mark? Oh, thank you. Okay, it looks blurry from over here. As long as they look clear. Okay, good. Yeah, good. Anything? Show me. Well, we drove from Toulouse in a small bus. Yeah, and we got to La Mongie, which is at the base of Peak, and then we rode the cable car up. Right. Oh, yeah, and that's the only way you get up there unless you're taking equipment up on that track. Yeah. So, Ed. No. That's a good question, and I don't know the answer to that. You know, maybe it's because the valleys and the passes were more amenable to getting up there. Although I don't know, because there are no roads up there. So, mm-hmm. Yeah, there are lots of them. The one I've gone with for years now is called MWT Associates. It's usually fairly small groups, depending on where you're going. You know, if you have a big thing like an eclipse, there'll be lots and lots of people, but if something like this has lesser interest, So there were only 16 of us, including the tour guide, Bob. Yeah, no, they have one there. Yeah, I didn't show it, talk about it. Yeah, because of that government building, and emergencies, they have, full access to that. Yeah, that was a good point. I just didn't show that. Yes. Okay, Rajesh? Yeah. No, oh, I'm sorry. I meant to mention that. Not that time. That's why we drug out the Dob, because they had some repairs they were doing to the .6 line. So we just happened to be unlucky at that point in time. But that's what they do with it. People who come up and spend the night get, a star show if it's not cloudy or something. Okay. Anything else? Okay. Thank you.
Did he go for a station? I'm here. Thanks, everyone. And Chris, I'm a little disappointed. I was hoping that you'd point out the coming fireballs we could see in the next month in your Sky This Month presentation. But I guess not. I'm going to talk about a fireball that we saw when we were in Arizona in February. Last month I talked about meteorites, but we also saw a brilliant fireball. And for the first time in my life, I decided to look and see if I could report it, because there were 3 of us that saw it at the same time. And I found a site eventually that I could report it and put it in, and found that there were others who reported it, and we saw the trajectory, and it was kind of neat. So I want to talk about that. How many of you have seen a fireball before? It's a good crowd. You mostly look up, so you see more than the regular population. How many saw a really, really bright one, like brighter than a quarter moon or something? Not too many. They say that to see one brighter than the quarter moon, you see that in maybe 200 hours of meteor observing. So, how many hours have you put in since the last one? You've got 200 hours for the next fireball. So, that's okay. So, what is a fireball? You saw this last month. So, meteoroid entering the atmosphere that's really large, bright, will be a fireball. So if it's brighter than Venus, say 3 to 4 magnitude, then you've got a fireball. Why does that keep bouncing around? Okay. And if the fireball explodes, then you've got a hole. So the Chelyabinsk meteor that came down, that was a super hole. So a fireball happens for those brief seconds that It's traversing from, say, 80 kilometers down into the lower stratosphere before it hits this portion here where it's traveling so slow, it's reached terminal velocity, and it's no longer ablating material and it's no longer giving off light. So your fireball you're seeing at a fairly high altitude. And if you wanted to report one, what do? And why would you report one? Well, there's a few reasons, and I found these in the RASC Observer Tent. It alerts meteor researchers, like the ones we have in Calgary and Western, an event for all sky camera network operators, and I think we have one at the Car Observatory, part of the network. It also adds to the global database whether or not these were meteor shower related, and it might not be. And it allows you to perhaps find a meteorite fall to assist in recovery if you get enough points to triangulate it, to see radar images, and can help in finding a meteorite that may have come from a fireball. They don't all produce meteorites, but some do. And of course, to rule out any catastrophic events. And this one I found interesting, that it can be used to help calibrate explosion detection for detection of violations of the Nuclear Test Ban Treaty. I never would have thought that, but it's an interesting reason to report them. So where do you report them? Now, if you're in Canada, there's a couple of options. You can report them to MIAC, the Meteorites Impact Advisory Committee, and there's a form you fill out on that website, and it gets sent to Calgary, University of Calgary, where it's recorded. Or the one that I used, and you can use this in Canada as well, the American Meteor Society. It's a wonderful site if you're interested in meteors. And they have, I believe they also have a mobile app you can use on your phone, so you carry it around all the time. You see one walking home, there it is. Failing that, you can also report Canadian ones by faxing a report with this kind of information, and they all ask for this kind of information, something to identify you, maybe some contact information in case they want clarification, of accurate time as possible, where you're located, where the fireball was in the sky, what angle it was going, where you started, where you saw it initially, and where the endpoint was. The estimated magnitude, say compared to Venus or the Moon, or it will be brighter than other stars at the fireball. And whether there was any trail, how long it was visible, and any other information, such as any colors you noticed, whether it broke up, whether there was any sound and what that sound delay was. And of course, if you had any evidence, video, photos, whatever, you'd be interested in that. So, this is definitely not important. Is it possible? Okay. So, this is the MIAC form, and the link is in the presentation. You put in your contact information up here, some information here about the fireball, when it was observed, what the location was. Did I do that? And then information, its brightness. So brightness relative to the moon, I think that is. No, sorry, this is the location. So stellar coordinates, altitude or azimuth coordinates, or relative to stars to pinpoint where this fireball was observed. And then characteristics, its brightness, so say the moon, duration, etc. Those kind of things that I had on the earlier slide that wasn't. But I use this website, the American Meteor Society, as a wonderful website. So you go there and you can enter all of this information using a nice app. And they have useful warning here to cut out some of the ones that are not fireballs, like the traditional plane going across the sky with lights, or whatever other events might be occurring, fireworks. So they try to eliminate those false positives, if you will. So this isn't this either. Anyways, I started to put in a fictitious one here. So here's the Science Center, and you can move a little person around. You can put in, where you are. So it brings up Google Maps. You put in where you were standing. So it gets your latitude, longitude. You put in the time, and you put in how long was it visible. And give you a nice pop-up chart and pick one of those. And then you put in information about where did it go. So they've got a nice little meteor there, and you can use a slider to slide it to show the angle that it was going down or going. It doesn't go up, it's going down. And similarly, they had an app to another screen where you can put in here after you put in your location and the direct this. Can you see the blue there? The direction you were looking and you saw it. And then here you can put the green line, the height above the horizon that it started at, the height where it stopped. You can put in the direction where it started and where it stopped on a map like this. I didn't put in all the charts. So it's very easy to use, even on a mobile phone. And then you put in an estimate of the brightness. And here they do it by relative to Venus, the quarter moon, the full moon, and so on. A lot of the really bright ones say that might result in a meteorite would be around -9 magnitude, which would be around a quarter moon brightness, I think. So you enter that information, and then they've got a chart here that it's a little hard to fill out the color that you notice in the meteor, because the colors will tell you something about what minerals were ablating on or burning off on the meteor, as well as something about the oxygen or nitrogen that was ionized. When a meteor comes through, about I think it's 95% of the color is from ablation material and 5% from the ionization. I think I have that right. But it's very, very hard on a bright fireball to tell the colors because of a problem of our vision, persistence of vision. So you see a certain color and it persists, and then you think you see another color and they sort of overlap, and you're not sure. So, and it's harder the brighter the fireball. But you give that a try, And I did for the one we had, the one we observed. And then when I went in and looked at the observations, because you could look at the other observations that other observers had, they had, some were the same, some saw different colors. We were all in different locations in Arizona. But it was very interesting to go and observe that. Oops, that's the wrong button. I lost my control. Oh, there we go. Okay, and then put in something about the sounds, if you heard any at all. Higher up, say 20 kilometers up or higher, you might hear sonic wave coming from. And what they recommend is to listen for maybe about 5 minutes after you see the fireball. I didn't know it at the time, but I found this out afterwards. Because sound travels only at about 20 kilometers a second, and if the meteorite's fireball is very far away from you, it's going to take minutes for it to arrive to you. Maybe seconds, but probably minutes. So listen to see if there was any sound coming from it. There are also these kind of phonic sounds that happen concurrent or at the same time as you see the fireball. They're not quite sure what it is. They think it has something to do with radio waves emanating from the meteor's passage through the Earth's atmosphere. So mention anything about that. And then, was there any persistent train or trail? Or higher up, there could be a smoke trail. And was there any flash at the end? In our case, there were 8 observations across Arizona, and only one person observed a flash or a breakup of the fireball. All the rest of us didn't see it. So you report that, and then you put in a little bit of information about yourself, and they give an opportunity here to say something about your observing experience, whether you have none or whether you're an experienced astronomer or an experienced observer. And that's, oops, doesn't want to go again. One more slide. There you go. So then you can come back a day or 2 days later. This is after about 3 days. A number of other people, I think there's 8 of us in total, put in observations. I was down here, the southern one, and the other people furthest north was around Phoenix. So this is about a 2-hour drive. So from that information, they calculate the meteor, the fireball's path, the meteor's path. And you'll notice it's going up here to east of Flagstaff, right around Wilcox, and strangely enough, that's where meteor crater is in Arizona. A 1 kilometer wide giant crater created thousands of years ago. So I wondered for a second whether there was another tiny one there from our little fireball. But I didn't read anything about it in the paper afterwards, or see anything on the websites, on this site. But you can go to AMS Fireball Reporting, and you'll see that there's fireballs reported every single week, practically every day, across the U.S. Good. Go one more slide. So these are the references from the meteorite talk. And the starred ones here, that one there on the top is the MIAC link. There's some interesting information there. And this is the American Meteor Society. And this is also another place where you can report your observation. And the Observer's Handbook also has a section that talks about meteors and mentions some things about fireballs as well. So good luck hunting for fireballs. Thank you, everyone. So, any questions that I might try to answer? Nope. Well, thank you very much.
All right. Thanks again, Brian. Now, at least I would say twice a year, I see messages in our emailing us saying, "Hey, did you see that bright meteor or fireball?" And people start talking about it. Well, I'm reported as well. Thank you, Brian. So that's it for speakers for the evening. I'll call on our president, Ralph Chu, to present the announcements.
Okay, thank you, Paul. All right, so just to get us started on upcoming events, our next meeting is on Wednesday, July 19th, and that will be another recreational astronomy night. Dennis Gray is going to be coming in to do the sky this month. Peter Hiscox is going to present on the new guideline on lighting of the city of Toronto, and this is something on controlling the night sky brightness in the municipality of Toronto. And then Frank Dempsey is going to give us an update on Solar Cycle 24. As far as sun is concerned, we have our regular solar observing. That will be on Saturday, July 8th. And Sean, as usual, will be our go, no-go announcer. And that will be on the forum, the Yahoo email list, as well as the various others. We do have one more night possible for this cycle of dark sky star parties tomorrow night, but who knows what could happen with that. But in any case, beyond that, the next one will be just after the next meeting, first clear night of 24th to 27th of July. City Star parties next week. First clear night, Monday through Thursday, apart. And again, the usual go, no-go messages in all of our meetings. And there we go. We have the Millennium Square stargazing night, the next one being at the end of July, and again, that will be something to watch for as well. That again, July. Okay, one thing that we are planning on is to participate in the National Star Party that's being organized on July 29th. This is something that the National Office is coordinating, and we're going to do our bit by having the Star Party here at the Science Center that evening. And so we're going to need volunteers to come out to sort of marshal our visitors. Obviously, we will need telescopes, and if you are available and can help out that night, please contact Ian Wilband using that email address to let him know that you can help out. And again, that would be very much appreciated. It should be a good show, assuming you have a clear stuff. Okay. The other big event for the summer, Monday the 21st of August, we have partial solar eclipse here in Toronto. There will be a lot of us who will be traveling south to get into the path of totality. But for those of you who choose to remain behind, we will have something going on here at the Science Center. And again, if you are available that day and would like to help out with the outreach effort and maybe do a bit of a celebration with fellow members afterwards, please plan on coming here to the Science Center that day. There will be more information about that as we approach the actual date. Speaking of eclipse viewing, I've got another couple of packages here of the RASC eclipse visors. Feel free to take one or two each if you like, and I still have some extras in my backpack, so feel free. Okay, our observatory, our observatory near Thornbury. Again, it's available for you to use throughout the summer. And this Saturday, we have the annual open house and awards picnic on the site. So the event starts at about 1 o'clock. If you can get there early enough to go on the hike around the Margaret Hall Loop. And then there'll be kite flying supervised at 2:30, rocket launches around 3:45, and I'll be arriving in time to do the awards presentations at about 5 o'clock, after which we'll fire up the big barbecue, and then we'll be observing after the marshmallow roast on the fire pit, which will happen. Observing will go on through the evening as long as you want to. Again, all of the accommodations have been booked. There is still space available for those who wish to camp in tents. A very long time on the driveway, things like that. And Dietmar can give you information if you're interested in finding out about the site itself, right? Okay, thank you. Okay, and we do have our managers of the Telescope Loan Program sitting in the middle of the room. And again, this is another one of those benefits of membership, the free loan of the various types of equipment. Try it before you buy it. See which of these types of telescopes work for you. So we do have that imaging package which is available, camera and telescope with a tracking mount. So again, all of those things are available to you to try out before you try to acquire your own equipment. And again, as usual, a few of us will be going over to the Granite for the meeting after the meeting. So please feel free to join us there if you can. And that's it. So we'll see you here in July on the 19th at the next meeting. Okay? Oh, okay. One more announcement before we go.
Okay. What I have brought here are, I talked about making solar filters, and what I brought are some of the starting materials. These are cardboard strips already cut. The wide ones are intended for telescopes, and the narrow ones are intended for binoculars. I used the pizza box and cereal boxes for the binocular ones, and I had special cardboard available to me for the telescopes. What I did find out that cereal boxes, you probably need about 8 layers to make a decent tube. For these ones, it's an extra thick cardboard, maybe 6 layers. 4. So you're welcome to come up and take some pieces. There are some people that already asked me. So first of all, we'll handle them, and then anybody else is welcome to come up and take some. I have ordered a large sheet, but it's on back order, and I'm not sure, what the timing is on that. But at any rate, even if you were interested in making one for future use, you're welcome to take some building materials.